Let's look at a simple application of this idea of equivalent force systems, and let's consider a body omega here. And I've subjected omega to two different force systems. So force system 1 over here consists of two 10-Newton forces applied in opposite directions at the corners of omega. And my second force system over here consists of two 20-Newton forces applied at different locations, so 2.5 meters in from the left and the right sides along the top edge. And the question is, are the force systems equivalent? So to show equivalency, I need to show that the net resultant of my first force system is equal to the net resultant from my second force system. So let's go ahead and we'll call this the prime force system. So for the first force system, I have 10 minus 10 EY, so that's equal to 0. So let's go ahead and we'll put our coordinates in here, x and y, so the usual one. And in the prime system, I have 20 minus 20 EY, so the unit vector in the y direction, so that's equal to 0, and so that checks out. R equals R prime, which is what we need. Okay, so, and now we also have to show that the moments are equivalent about some convenient point. So for my convenient point, I'm going to go ahead and pick the point right here in the middle. I'll go ahead and call that A, and here it is, A. So the distance from the edge of the box here to A is 5 meters, and it's exactly the same in this picture here too. Okay, so the moment, the resultant moment in A on the side over here, well, this is going to be 5 times 10. So the lever arms times the magnitude, so this is the force on the right side, and then we have plus minus 5 times minus 10 on the right side, easy. So this is going to give me a net moment of 100 Newton meters about the z-axis. Now if we go ahead and compute it for the prime system, so the resultant in A, now the lever arms are different. We have a lever arm of 2.5 meters times 20 newtons going upwards, plus a lever arm of minus 2.5 meters to the force that's going downwards with 20 newtons. So this gives me an EZ, and if I calculate that out, I'm going to get 100 EZ Newton meters. And so if we look at these guys are equal to each other, so that checks out. We've shown that we have the same resultant force for the two force systems, and we've shown that we have the same resultant moment for the two force systems in one given reference point, and that means it holds for all reference points. So the answer here then is yes, equivalent.